Good morning, everyone. Welcome back to another lesson for Algebra 2 with Pre-Calculus. This is Mr. Malcolm. Please ensure that you take the next 90 seconds or so to update the title for today, which is Lesson 9.06, and the date, and the topic, which is transformations of sinusoidal functions. Please make sure you get that going. Also, I would like you to have your graphing calculator out. And as usual, if you don't have one, or if you find this more useful, I'll be using Desmos graphing calculator, and the link is right there. You can type that into your search bar to get it. Please pause the video at this time and get ready, and I'll see you in a couple of seconds. All right, welcome back. Thank you for pausing the video and doing what you were supposed to do. We're going to dive right into the Think About It section. Now, our Think About It section today has 3 questions, and this is what the overall thing that we're supposed to do says. Use period, amplitude, and midline of the y equal cosine of x function to answer the following questions about transformation form of sinusoidal function. Now, here they give you what the function y equal cosine of x looks like, and then they give you 3 different transformations of this function. So what they would like you to do is to identify the period, amplitude, and midline of this function, which is -3 cosine x function below. So let's take a look at it. The original, the amplitude goes from 0 to 1. In this one, the amplitude goes from 0 to 3. So our amplitude would be 3. What about our period? Our period goes from 0 to 2 pi. So it's the same as before, from this line all the way to this line, from 0 to 2 pi. So it's the same as before. So our period is 2 pi, just like before. What about our midline? Our midline is going to be the line that cuts the graph in half. As you can see, the line that cuts the graph in half is our x-axis, otherwise known as y equals 0. Okay. Now, I took the liberty of drawing out this function, this overall function that you can use as a means of calculating these without having to look at the graph. So if you look, each one of these functions will have this format. It says f of x, or function of x, is equal to a, which is the amplitude, times the sine, or times b times x minus h. B shows the shrinkage, vertical shrinkage, or expansion, or the horizontal shrink or expansion, I should say. The H represents the phase shift from left to right, and K has to do with your midline. So this is where you can use, this is what you can use to get the value of y. So for instance, if you look on your graph, if you found what A was, it says that A right here is -3, and our amplitude is always an absolute value. So the absolute value of 3, or -3, would be 3. Okay? If you look where it says for B, there's no value there for B. So our period should remain the same. Nothing was done with B. For H, there is no value for H here in our equation, so we know that there is no phase shift left or right. It's the same. And the K value, there is no K value in this equation. As a result, we know that Y must represent nothing, or Y equals 0. Okay? So this is another way that you can use to get this information. Let's try 2. Or let's answer the question over here first. How did the equation of f of x indicate the difference between its graph and y equals cosine x? So again, the difference is just that the amplitude changed. Everything else remained the same because there's no b value, there's no h or k value. Okay, so let's look at number 2, the amplitude. Amplitude based upon our equation here, there's no number in front of the cosine, so that means that the a value is non-existent, so the a value should remain like the original. Okay, so what was the original? The original amplitude is 1, so we rewrite 1. What about our period? Okay, this time there's a 2 in front of our x value, so that would give us a b value. Now, in order to calculate the period from the b value, we would do 2 pi divided by b. Okay, so that would mean that we have 2 pi divided by b in this equation is 2. So it should be 2. And you can cancel the 2's, which would leave you with pi. So in this case, our p value is pi. What about our midline? Is there a value in here for k? Think about it for a second. And if you guessed that the answer is no, then you're surely correct. Okay, there is no k value. So our answer reverts to the original, which says that our midline is y equals 0. Okay, perfect. Number 3. Number 3, now we have a h and a k value. So let's test it out for amplitude. Okay. So for an amplitude, we have no new numbers there. So we should revert to the original, which is 1. For a period, is there a b value? No. So since there is no b value, then we should revert to the original, which says 2 pi. Okay. So it should be 2 pi. But now our midline, which has a 4 there, now indicates that we have a new midline, which would be y equals 4, just like what it says here. Y equals to the k value, okay? Our k value in this equation is 4, okay? Now let's try to answer the last piece of question here. It says, how did the equation of h of x indicate the differences between its graph and the y equal cosine of x? So there's a few differences. Let's start with the similarities. The similarities state that the amplitude and the period would be the same. However, the midline, based on the k value, changes. So the graph went up by 4 units. And the next thing is the h value. It now has, the h value says it's pi over 2. So that would mean that there is a phase shift to the left at pi over 2 degrees. So if you notice, our original has the starting point up by 1, or it starts at the maximum. In this graph, it does not start at the maximum. It starts somewhere about halfway from the maximum. It starts at the midline. So that would mean that the graph was shifted over to the left by pi over 2 units. Okay? Now, to better illustrate all of this, we'll use our graphing calculator. But one other thing that I just noticed is that in question 1, if you notice that this graph is flipped upside down, and that's because there's a negative in front. Okay? So the negative just means that you invert the equation, or you invert the graph. So I'll show you all of this from the graphing calculator. So this is what the original would look like. The next equation says -3 cosine x, and as you can see, it inverted and it's stretched. Okay, it's because the amplitude increased. Okay, the third one says cosine of 2x, cosine 2x. Okay, you can see how different this one is. It shrunk, right, based upon the b. The b tells you if it shrinks or it expands. Okay, and the final one says cosine of x minus pi over 2 plus 4, cosine of x minus pi over 2 okay, minus 4. Oh, plus 4. Plus 4, okay? And as you can see, the graph moved up by 4 units. There was a phase shift. There was a phase shift to the left by pi over 2 units, and that's the basic difference between the two. Okay, so I hope this helps and that you are now able to see the difference between the two, and between the different kinds of phase shifts that we have, and how it is that you move them from left to right, up and down, shrink them or expand them, to invert it, and all of these things. Okay? All right. I hope this was helpful, and I'll see you in class.